have a good day everyone. In the last lecture already we have discussed about rectifiable curves, regular curves or arcs, contour, closed contour and some properties of rectifiable curves. Now here we define the complex integration. Now let gamma be a rectifiable curve. Okay, gamma be a rectifiable curve whose equation is z equals to z of t, where a less than equals to t less than equals to b, and let f be any complex function. Okay, any complex function defined on this gamma, and let P be a partition of closed interval AB, and that is equals to A equals to T0 less than T1 less than T2 up to less than Tn equals to B. Be any partition of closed interval AB. Now corresponding to the partition P, corresponding to P, gamma is divided into n smaller arcs. Suppose sigma k equals to zk minus 1 minus zk, where k equals to 1, 2 up to n, and here zk equals to z of tk, here k equals to 0, 1, 2 up to n. Now let suppose this is a curve gamma. Here the points z0, z1, z2 up to zk minus 1, zk plus 1 up to zn minus 1, zn. Okay, zn. Now this arc is sigma 1, this arc is sigma 2, this up to this arc is sigma k, up to this arc is sigma n. Okay, now let zeta k be an arbitrary point of sigma k. Okay, the point is zeta k. We form the sum at this point zeta k. Sp equals to summation over k equals to 1 to n f of zeta k zk minus 1. Clear? Now if limit norm p tends to 0, Sp, that is equals to limit norm p tends to 0 summation over Sp means summation over k equals to 1 to n f zeta k zk minus 1 zk. Okay, here norm p equals to maximum over tk minus 1, where k equals to 1 to up to n. Clear? This limit of SP exists and is equal to J, which is independent of zk and zeta k. We say that f is integrable on the curve gamma, and we write as j equals to integration over gamma fz dz. Okay, this is the function f is integrable on the curve gamma. Now since as norm p tends to 0, maximum over 1 less than equals to k less than equals to n, mod of zk minus 1, that is tends to 0. So we can write j equals to limit over maximum of zk minus mod zk minus 1 tends to 0 over 1 less than equals to k less than equals to n, summation over k equals to 1 to n f zeta k zk minus zk minus 1. Clear? And now the sufficient condition for integrability what if f is continuous, on a differentiable rectifiable curve gamma, then f is integrable on gamma. Okay, this is the sufficient condition for the integrability of function f. If f is continuous on a rectifiable curve gamma, then f is integrable on gamma. Clear? Now we have to easily prove that if gamma is a rectifiable arc joining the point A and B, then integration over gamma dz equals to b minus a. Second thing is integration over gamma k dz equals to k of b minus a. Here k is some constant. K is some constant. Okay. And the third thing is integration over gamma if z dz equals to half of b square minus a square, where if z equals to z, that is the integration over gamma z dz equals to half of b square minus a square. Okay, we can easily prove this one and this one. Now here we have to prove this third. Here if z equals to z, which is continuous on gamma, and so the integral exists. Okay, now we divide gamma into smaller arcs by the points. Say a equals to z0, z1 up to zk minus 1, zk up to zn equals to b, and from the sum s equals to summation over k equals to 1 to n if zeta k zk minus 1, where zeta k is a point on gamma. Okay, between zk minus 1 and zk. So here we take zeta k equals to zk minus 1 and zeta k minus 1 equals to zk. Then the sum S1 equals to, for this S1 equals to summation over k equals to 1 to n f of zk minus 1 zk minus 1, and for this the sum S2 equals to summation over n equals to 1 to k if zk of zk minus 1, and that is equals to summation over k equals to 1 to n, that is z k minus 1 zk minus 1, and that is equals to summation over k equals to 1 to n zk minus zk minus 1. Now since integration over gamma f z dz exists, okay, so the limit maximum of mod zk minus 1 tends to 0 of s limit s1 over maximum mod of zn minus zk minus 1 tends to 0, and limit s2 over maximum mod of zk minus 1, this is tends to 0, all exist, okay, and tend to the same limit integration over gamma f z dz. Therefore 2 into integration over gamma z dz equals to limit max over mod zk minus 1 tends to 0 s1 plus s2, that is equals to limit max mod of zk minus 1 tends to 0 zk square minus zk minus 1 square, okay, so that is equals to limit max over z mod of zk minus 1 tends to 0 zn square minus z0 square, that is equals to zn square minus z0 square, so that is equals to v square minus s square. So ultimately we obtain integration over gamma z dz equals to half of v square minus s square, okay. Hence this result we have obtained, okay. Now some elementary properties. If f and g are continuous functions over a rectifiable curve gamma, then the property 1 is integration over gamma fz plus minus gz dz, that is equals to integration over gamma fz dz plus minus integration over gamma gz dz, okay. Property second is integration over gamma k fz dz, that is equals to k of integration over gamma fz dz, where k is a constant. And the third is if minus gamma denotes the curve gamma, describes in the opposite sense. Then integration over minus gamma fz dz, that is equals to minus integration over gamma fz dz. And the fourth property is, if gamma is a rectifiable arc consisting of finite number of rectifiable arcs like gamma 1, gamma 2 up to gamma n, that is gamma equals to gamma 1 plus gamma 2 plus up to plus gamma n. Then integration over gamma fz dz, that is equals to summation over I equals to 1 to n integration over gamma I fz dz. Okay. Now we study the integration along a regular arc. Let f equals to uxy plus ivxy be a continuous function, on a regular arc gamma, whose equation is gamma such that z equals to z of t, that is equals to xt plus I yt, where a less than equals to t, less than equals to b. On the arc gamma, f becomes a function of t as follows: fz equals to u of xt y of t plus I v of xt comma y of t, that is equals to u of t plus I capital V of t. Say for a less than equals to t, less than equals to b. It can be proved that f is integrable, and integration over gamma fz dz, that is equals to integration over a to b u of t plus I capital V of t into x dot t plus I y dot t dt. Clear? More generally, it can be shown that if f is continuous, on a contour gamma, it is integrable along gamma, and the value of its integral being the sum of the integrals of f along the regular arcs which of which gamma is composed. Okay. Now an inequality for complex integral. Here we study a theorem. If f is continuous, on a contour gamma of length L, and if there exists a positive number capital M such that mod of fz less than equals to m for all z belongs to gamma, then mod of integration over gamma fz dz less than equals to ml. This formula is also called ml formula. Okay. Now here we solve an exercise like let fz equals to 1 by z square, okay, and gamma with a straight line joining the points I and 2 plus I, show that mod of integration over gamma fz dz is less than equals to 2. So the solution is here I equals to, the point is 0 1 and 2 plus I equals to 2 comma 1. So that means, and the line joining the straight lines, then so this is I and this is 2 plus I because ordinate is 1. Okay, here L, the length, equals to 2 plus I minus I, that is equals to 2. So on gamma, mod of fz equals to 1 by mod z square, because fz equals to 1 by z square. So here mod of fz equals to 1 by mod z square, that is equals to 1 by z equals to x plus iy, so that is square, that is equals to 1 by x square plus y square, so that is equals to 1 by x square plus 1, because here the points 0 1 and 2 1, so ordinate is 1, so y is 1. Okay, and that is obviously less than 1, so this one equals to say m. So by ML formula, mod of integration over gamma if z dz, that is less than equals to m into L, that is equals to 1 into 2 equals to 2. So mod of integration over gamma f z dz, that is less than equals to 2. It is proved. Now the second exercise is evaluate integration over c dz by z minus alpha whole to the power m, where m is any integer, okay, and c denotes the circle c such that mod of z minus alpha equals to r, described in the positive sense. So what is the solution? This is the circle in the positive sense, and this is the center alpha, this is radius r, okay, this is the circle. So z minus alpha equals to r into e to the power I theta, where 0 less than equals to theta less than equals to 2 pi. Clear? So from here we can easily get the value of dz, that is equals to r from this relation, r I e to the power I theta d theta. So integration over c dz by z minus alpha whole to the power m, this is equals to 0 to 2 pi r I e to the power I theta d theta whole divided by r I theta whole to the power m, that is equals to integration over 2 pi I by r to the power m minus 1 e to the power I of 1 minus m theta d theta. Okay, now here m is any integer, so here we take if m equals to 1, then integration over c dz by z minus alpha from this integration equals to integration over c dz by z minus alpha equals to I of integration over 0 to 2 pi d theta. that is equals to 2 pi I, and when m not equals to 1, if m not equals to 1, then integration over c dz by z minus alpha whole to the power m, that is equals to I by r to the power m minus 1 e to the power I of 1 minus m theta by I of 1 minus m, limit is 0 to 2 pi. Okay, so that is equals to 1 by 1 minus m into r to the power m minus 1 e to the power I 1 minus m 2 pi minus 1, that is equals to 0, since m is an integer. So if m equals to 1 and m not equals to 1, when m equals to 1, the integration equals to 2 pi I, and when m not equals to 1, the integration is 0. Okay, now the another example is evaluate integration over c z bar dz, where c is the upper half of the circle mod z equals to 1 from z equals to minus 1 to z equals to 1. Okay, the solution is, this is the upper half of the circle, this is minus 1, this is 1, so here z equals to e to the power I theta, this is the parametric equation of the circle. So theta varies from pi to 0, that is pi greater than equals to theta greater than equals to 0. So from here dz equals to I e to the power I theta d theta, therefore integration over c z bar dz equals to pi to 0 e to the power minus I theta I e to the power I theta d theta, that is equals to I of 0 minus pi, that is equals to minus I pi. This is the result. Okay.